Hello everyone. Today we will discuss about a question from GATE 2025. The question is from linear algebra. The question says that let PAX denote the characteristic polynomial of a square matrix A. Then for which of the following invertible matrices M the polynomial PMX minus PM inverse X is constant. Here we use the concept of eigenvalues. We know that trace of a matrix A, this is equal to lambda 1 plus lambda 2, where lambda 1 and lambda 2 are two eigenvalues of A. Suppose A is a 2 cross 2 matrix. A is a matrix of 2 cross 2 and this is eigenvalues of A. Trace of A is equal to lambda 1 plus lambda 2 and determinant of A, this is equal to lambda 1 into lambda 2. And for a 2 cross 2 matrix A, its characteristic polynomial is equal to x square minus lambda 1 plus lambda 2 into x plus lambda 1 lambda 2. Now here given that M is an invertible matrix. M is an invertible matrix. So determinant of M not equal to 0 always. This implies product of two eigenvalues of M, this not equal to 0. Suppose lambda 1, lambda 2 be two eigenvalues of M. Then here lambda 1 into lambda 2, this is not equal to 0. Now lambda 1, lambda 2 not equal to 0, this implies lambda 1 not equal to 0 and also lambda 2 not equal to 0. So if lambda 1, lambda 2 be two eigenvalues of M, then 1 by lambda 1 and 1 by lambda 2 are eigenvalues of M inverse. Since both lambda 1 and lambda 2 not equal to 0, so this must be defined. Now characteristic polynomial of M, Pmx, this is equal to x square minus lambda 1 plus lambda 2 into x plus lambda 1 lambda 2, and Pm inverse x, that is characteristic polynomial of M inverse, is equal to x square minus 1 by lambda 1 plus 1 by lambda 2 into x plus 1 by lambda 1 into lambda 2. Now here we have to find those matrix M such that Pmx minus Pm inverse x, this is constant. Now Pmx minus Pm inverse x, this is equal to, so minus lambda 1 plus lambda 2 plus 1 by lambda 1 plus 1 by lambda 2 of x plus lambda 1 lambda 2 minus 1 by lambda 1 lambda 2. This term is constant. So this subtraction Pmx minus Pm inverse x must be constant when the coefficient of x, that is this, is equal to 0, because x is not constant, it's a variable. So we have to find those values of lambda 1 lambda 2 for which lambda 1 plus lambda 2 plus 1 by lambda 1 plus minus of lambda 1 plus lambda 2 minus of lambda 1 plus lambda 2 minus of lambda 1 plus lambda 2 plus 1 by lambda 1 plus 1 by lambda 2. This equal to 0. Therefore, minus lambda 1 plus lambda 2 plus 1 by lambda 1 plus 1 by lambda 2, this must be equal to 0. This implies lambda 1 plus lambda 2 is equal to 1 by lambda 1 plus 1 by lambda 2. This is equal to lambda 1 lambda 2 into lambda 1 plus lambda 2. This implies lambda 1 plus lambda 2 into 1 minus 1 by lambda 1 lambda 2. This is equal to 0. This implies either lambda 1 plus lambda 2 is equal to 0 or 1 minus 1 by lambda 1 lambda 2 is equal to 0. This implies lambda 1 lambda 2, this is equal to 1. Therefore, the difference between Pmx and Pm inverse x is constant when for those matrices M for which eigenvalues of M, sum of eigenvalues, either sum of eigenvalue is equal to 0 or product of eigenvalues is equal to 1. The two condition is lambda 1 plus lambda 2 is equal to 0 or lambda 1 into lambda 2 is equal to 1. Here in the option A, M is equal to 1, 3, 2 minus 1. Now determinant of M is equal to what? Minus 1 minus 6. This is equal to minus 5. This is equal to lambda 1 lambda 2. It's not equal to 1. Now we have to find lambda 1 plus lambda 2. This is equal to trace of M, that is 1 minus 1, this is equal to 0. So one condition is satisfied. Therefore, for this M, Pmx minus Pm inverse x is constant. Now for option B, M is equal to 3, 1, 4, 2. Here lambda 1 lambda 2, this is equal to determinant of M. This equal to 6 minus 4, that is 2, not equal to 1, and lambda 1 plus lambda 2, trace of M, that means 3 plus 2 is equal to 5, this is also not equal to 0. Therefore, both conditions are not satisfied. Therefore, for this M, Pmx minus Pm inverse x is not constant. So, option B is incorrect. Now, for option C, M is equal to 5, 7, 2, 3. Here, lambda 1, lambda 2 is equal to determinant of M. This is equal to 15 minus 14 is equal to 1. Therefore, one condition is satisfied. Pmx minus Pm inverse x is constant for this M. Therefore, option C is correct. Now, for option D, M is equal to 5 minus 8, 2 minus 3. Here, determinant of M, this is equal to lambda 1 into lambda 2, this is equal to minus 15 plus 16 is equal to 1. So, here also one of the condition is satisfied. So, one condition is satisfied. Therefore, for this M also, Pmx minus Pm inverse x is constant. So, option D is also correct. The correct options are A, C and D. This is MCQ type question. So, more than one option can be correct. Correct options are A, C and D. Thank you.